Good afternoon, everyone. I'm Goodman Gu from Adobe.
I'm Andrew Gu. I'm a competitive pianist, and I also am a machine learning engineer at iSpace Institute.
So we're going to tell you a bit more about work on AKAP. AKAP stands for Agentic Knowledge Asset Platform. So this is a collaboration with our colleague at Wharton School, Martin Ari, is a well-known scholar in the strategic management area. So we're here to uncover two mysteries. The number one is called the knowledge asset paradox. Why is paradox? It's because we come from all different kind of organizations. Each organization has tremendous amount of knowledge, very valuable knowledge assets. But oftentimes they are segregated, hidden away in different departments. Sometimes knowledge is stored in organically, called organic because it's stored only in someone's brain, not written down. But how big is the problem is? Google actually did a study. Google Cloud did a study. About 80% of enterprise data actually are unstructured. Because data is unstructured, it's hard to make sense of it. Navigate it, right? About half of the critical knowledge actually are in individuals. Some critical individuals, experts. They don't share. For obvious reasons. Someone says job security, right? So it is estimated if we actually can unlock the value for those kind of underutilized assets, this market for AI-based knowledge asset management systems, software, is as big as 250 billion market. We're here at the top business school. It's never wrong to chase money. So, but how can we tackle this? We have 3 steps. Step number 1 is of all the knowledge assets, how do we actually classify them? When I say knowledge asset, it's not just any piece of knowledge. It is oftentimes intangible resources in enterprises. When you unlock it, has tremendous amount of strategic value. Okay, these are what we meant by knowledge assets. Examples are some of the high-profile individuals, experts like my former colleague at Apple, Roaming Pang, recently got hired by Meta, made the news, $200 million sound package. That's the significant loss of value for Apple for sure. That's why Zuck is willing to pay for that. So IPs, patents, right? So like key domain specific product knowledge, right? Even customer insights. If you have deep insights of certain critical strategic partners for you, or institutional knowledge in culture. Google has very good enterprise culture. They actually get to talk about their system called Aristotle. That's one of the secrets underpinning the tremendous growth of Google over the years. Even technical knowledge, right? Some IPs, algorithms. There's all kinds of actually 5 domains of different assets. So that you can consider this as a way to kind of classify knowledge assets in different domains. Step number 2 is how do we actually understand the state or stage for knowledge asset? So I got to introduce to this concept called iSpace. When I attended Wharton's Advanced Management Program this spring, I attended from March to June. So I got to learn Kartik as well. So this is from a scholar called Basul. He basically says, for any piece of knowledge asset, you have to look at it 2 dimensions. On one x-axis, you want to see how the knowledge is shared, how much is diffused. On the vertical side, you need to understand how much knowledge is codified, where it's structured, right? Then you can put basically all your knowledge on this map to get a snapshot for all states for your knowledge assets. So that's the preparation for step number 3, is you understand the classification, you understand the state or status. Now you get to know the value, right? That's the critical part. How do we model the value? This is based on Martin's work, and we further developed this. Basically, for every piece of guess it's pointer here, right? Yes. Oh. Okay. So anyways, so for every piece of knowledge, let's say I, at any time t, the value for the knowledge asset is determined by, there's a baseline value for knowledge assets. The more you codify it, meaning more structured, it has more value, right? But the more you diffuse it, share it, controversially, it is actually decrease the value. That's why the second paradox is called the paradox of value. How do you strike a balance between codifying more versus diffusing more? And of course, there's a time value for the assets over time the knowledge gets obsolete. Using this kind of a formula, we'll be able to determine for any piece of knowledge asset in the enterprise for the whole portfolio. That gives understanding for your portfolio value, right? So I often show, this is pretty much like you determine net worth for individuals. First, you need to know what kind of jobs this person has, what industry. You have to see what stage of a career it is, like the status. Now you have to determine somehow with a formula net worth. But the value is never be the maximum if it stays just static, right? The value is going to increase when it is in motion. We got to make moves. So just like example here, for any kind of test knowledge stored in someone's brain, if we can actually structure that, codify it into patent, okay, then more people, before the patent is fully published, more people inside the company get to know that piece of structured kind of knowledge. When it gets published, we build products out of the patent. We, publish papers, give talks. What I'm doing right now here is to diffuse it. It becomes public knowledge, right? So when it becomes public knowledge, our competitors will pick it up. They build similar products, compete with us. They grow the ecosystem. And they innovate together with us, makes a much richer ecosystem. So what we can do is we absorb that information, internalize it, bring back to our enterprise, and we further develop it. So R&D, research and development, and generate more passive knowledge. Instead of one expert, we now have more experts, a few, 5, 6, 10. So that cycle continues. This kind of flywheel effect is really how we actually increase the value for your knowledge portfolio. With that, I'm going to hand over to Andrew to tell you how we actually build this.
So our co-author, Martin Eyrig, has been running basically a knowledge asset consulting business called the iSpace Institute for many years. However, Martin has been doing all of this manually. So as a result, only a very few select, very high value companies are able to benefit from this. So the next question we asked ourselves was, how can we take manual knowledge asset management and really make it scalable, automated, and intelligent? So that's what led us to develop AKAP, which is the Agentic Knowledge Asset Platform. And here are the 7 agents that power the AKAP engine. So it begins with the data ingestion agent, which extracts knowledge assets from your enterprise systems. Then the classification agent maps knowledge assets onto the iSpace framework that my dad showed before. Then the codification agent transforms tacit knowledge into structured documents. Well, then the dissemination agent makes the knowledge assets available to more people, either within the company or outside of the company. The productization agent turns structured internal documents. The productization agent turns the structural documents to create new products and to create new standards within the company. And the contextualization agent adapts documents for new domains. Finally, we have the discovery agent, and that turns the outside knowledge from when the product and the information, the tacit knowledge, is outside of the company and is developed in other companies, competitors, to conduct R&D to produce new tacit knowledge. And together, these agents codify and diffuse knowledge assets at scale to enhance their value. So we want to work with sort of definition in the purview of what we have as an agent. So it's an automated AI software that can perceive its environment, reason to formulate goals and plans, and take actions to achieve its goals. Crucially, it has memory to learn and improve over time. The knowledge asset environment is very messy and always constantly changing, so we use operating engines that can perceive, that can decide, and can act continuously. So, next. Yeah. The core of our contribution is formalizing the entire value creation process as a cooperative multi-agent reinforcement learning problem, or also known as MARL. So basically, we model it as a decentralized POMDP, which is a partially observable Markov decision process by the set of the agents and the corresponding variables. All of the agents share the same value. We're trying to maximize the objective R, increasing total portfolio value of knowledge assets. And this value reflects the utility of codification, the decline in scarcity as knowledge diffuses, and the risk of obsolescence. So coordination across the entire system is what learns to raise R. Next. So AKAP also adds a metacognitive loop. So it looks at long runs of states, actions, and rewards, and compares them to KPIs that we care about. And so the agents are all aligned with business goals, and a hybrid reasoning engine generates plans. Then a self-critique system checks them, and a trace repository records all of the reasoning for audit and for reuse. A multi-pass verifier keeps iterating until the solutions hold up, and the memory that we have ties it all together so none of the data gets lost. Put simply, this loop is AKAP's control plane. It makes sure the system is always learning in step with strategy as it shifts. Next. So we built an enterprise knowledge portfolio with simulated data. The left chart over here compares 2 agent coordination strategies across a span of 8 quarters. Standard myopic or IGM-based approach. That's the one in light blue. And also we have Dave. So it's a sort of non-monotonic approach. It's IGM-free, and it deliberately takes short-term hits in the beginning, like diffusing a newly codified asset to a pilot team, so it can sort of collect more feedback and refine the data, and can create a higher value asset later down the line, as you can see. So the initial sacrifice shows up as a dip, but by the eighth quarter, you can see that Dave has a higher knowledge portfolio value than the myopic baseline. The right chart simulates when a key expert that has a lot of knowledge assets leaves, and this donut shows how much portfolio value disappears when their tacit knowledge wasn't codified. However, also proactive codification and targeted diffusion dramatically reduces the loss when that key holder of knowledge assets leaves the company. So the data here comes from a run. We simulated 200 assets across different categories, such as like intellectual property, tacit knowledge, which allows us to basically stress test the different strategies under the same conditions. All right. AKAP has a 3-tier architecture, starting from ingesting data at the bottom from enterprise systems. So that might be like your Microsoft, your Zoom, your internal documents, stuff like that, patents. We have an API that can just take all the patents from like a company. So we use them, we taxonomize them to store them, and use agents to increase and maximize value from each of the assets that are found there. Based on this, it enables various applications of strategic knowledge management. So in conclusion, we're able to sort of bridge iSpace with information economics and cooperative multi-agent reinforcement learning to sort of automate and scale enterprise knowledge management, knowledge asset management, and we have some promising results. So in the future, we'll benchmark this multi-agent reinforcement learning with like QMix, with DVD, and other Dave variants, and incorporate value of information to help understand the incremental value from a piece of information. So we'll also invest in capturing tacit knowledge with richer interactive protocols. For example, cognitive task analysis, and bring explainable AI into the loop so that managers can trust and audit the system's choices. So we've actually developed an AI system that can automate and scale enterprise knowledge asset management. Everyone can join for free using your Google account or just signing in, and we're going to do a quick demo of that right now.
Escape.
All right. So I'm going to walk you guys through how, is it full screen? Okay. So to get started, we first want to get all of our knowledge assets in place that we mentioned before can be derived from workplace ecosystems and other sources. But if you want to, you can create your own knowledge assets here and sort of create your own knowledge assets and add it to your portfolio of the company. And after that, once you have that, you can, yeah, this one right here. All right, so now that we have the knowledge assets mapped out, you can see sort of where the knowledge assets lie within your company. So we have all the assets in different stages of the social learning cycle. We can also see the asset distribution by subcategory, like what they are in terms of their patents, if they're leadership knowledge, just different types of knowledge within your company. Here we can see just all the knowledge assets listed out. This is simulated, but you can see the different tags that each of the assets have. So stuff like that. You can click on them so you could kind of see the composition of them and the asset metrics in terms of strategic value, protection level, and how codified they are. And finally, we have an interactive demo where we compare like an IGM constrained model with our Dave model, which we mentioned before. And if we run a simulation with you can sort of see like the dip that we mentioned before in terms of initial loss, but the long-term overall success of using the Dave model as opposed to the sort of instantaneously what independent agents to maximize the value, sort of looking at them together through the dual assessment would make it better over the long term. So you can see that there's a huge advantage over an 8-quarter period. So, yeah.
Great, thank you so much for that.
Yeah.
Very interesting work. The question I had was, what is the objective function in your reinforcement learning model? That wasn't very clear. What are you trying to maximize?
It's the value.
Okay, it's 2 tiers. So there's a very high level, the whole portfolio. And because it's a multi-agent kind of collaboration, we want to maximize the total portfolio value of the assets. That's the kind of overarching goal. And at individual agent, it has this also local value, right? You want actually find a balance between maximizing individual value and as well as the total portfolio across.
So the portfolio value is based on the knowledge gleaned from a particular source?
Remember I shared a formula with you?
Equation?
Early on. Yeah, that's the objective function. So this is for each individual piece of asset. The objective function is you have to basically summarize them together. That gives you portfolio. So the overarching kind of objective is to maximize that portfolio value of this. Okay, does it make sense?
Yeah, my only concern here is that the value, right, is
Yes.
going to be quite subjective, right? I might value one asset very highly,
Yeah.
whereas he might value it, at a low level because
Yes.
he may already be aware of that
Yes.
asset. So it's quite subjective, right? I mean,
Yes.
there's no objective.
Yeah, it is only
measure of
to your organization. That's why when we actually data ingestion, the enterprise define their own how they evaluate. Because you see the form I showed you, there is a field that says how do you define the value, how much value to you. You can always calibrate.
So this is going to be sort of this objective function is going to be maximized at the organizational level.
Yes.
Yes.
Yeah.
Finish this time, let's take a Q&A online.
All right.
Yeah.
Thank you.
All right.
All right.